Hey everybody. So the guess method is the method that we're going to be using for solving word problems in physics. And a lot of the problems we're going to encounter in physics are going to be word problems because you kind of have to set up the scene so you know what the scenario is and identify the different parts of the story that are going to be useful in solving the problem. So without further ado, here is an example of how to solve the guess method. So we've got a problem here. We've got a car that's traveling. It's going to accelerate at a rate for a certain amount of time. What is the car's final velocity? After you read the story without numbers, then we're going to start to identify what parts of this, what numbers are we going to use, and how do we identify them. So we've got 7 meters per second there, and 0.8 meters per second squared, and 2 seconds. So the meters per second right here indicates that we're talking about a velocity. So it's traveling already at 7 meters per second. So that's the initial speed that it's traveling. It also tells us a rate of 0.8 meters per second squared, and that's an acceleration. So anytime you see meters per second squared, you can look at the acceleration. And finally, we have 2 seconds, so that's going to be our time, delta t. So now we have to identify the unknown. It's asking about the final velocity, so that's v with a sub f. So we're just going to leave that a question mark. Now we have to find the equation. And we're going to use our equation sheet to do that. That's under the Resources tab of our classwork. Now we've got about 4 to choose from there. Those are the kinematics. We're going to choose the one that helps us out given our variables. So we're going to go into third week. We're going to choose which kinematic, and this decision-making chart will help you. Here we have VI, A, delta t, and VF. And so we're going to find that on this chart. We need VF, VI, delta t, and acceleration, and it doesn't have a delta x. So that's going to be this first equation. So that's the one we're going to choose. So we're going to bring that back over to our chart, to our guess method. We're going to pen that in. VF equals VI plus A delta t. This even has our VF isolated, just like we want it to be for the unknown. So we'll set VF equal to, and we'll plug in our values, our substitutions, and solve. That should just be seconds, right? 2 seconds. So we solve this out in 2 steps. Do our algebra, show our work. 1 unit of seconds is canceled out. And now we have meters per second plus meters per second, so we can add them together, and we get 8.6 meters per second. That's our answer, but we want to put our solution separately, and we want to make sure that it's fancy for the dancy. So we've got 2 sig figs all the way across, so our answer should have 2 sig figs. Final velocity equals 8.6 meters per second. Make sure that makes sense with the rest of the problem, and box in our answer, and we're done.